This assignment focuses on linear algebra. In particular, we look at how linear algebra can be used to examine the B matrix, which we're familiar with now, to get various important properties of structures. We've probably learned in undergraduate statics about concepts like static determinacy and stability. Particularly, stability is something that can only be determined by inspection for very simple structures. For complicated structures, we need a more formal approach to determine stability, and linear algebra comes into play here. So in this assignment, we'll look at this somewhat complex three-dimensional structure called tetrahedral octahedral truss, and we will see if it is stable and what its degree of static indeterminacy is. In particular, we'll look at what are called internal mechanisms. Internal mechanisms are loose parts inside a structure that are not held stable. You might wonder, why would there ever be unstable internal mechanisms in structures? There are certain structures like deployable structures, for example, the space structure in the truss structure in the space station, which needs to fold up and then get deployed. So there need to be parts that are not stable inside the structure that can be stabilized by applying pre-stress. And in this assignment, we'll also explore what it means um, for a structure to be statically indeterminate and what pre-stress modes are. So there will be a sequence of videos mostly covering linear algebra concepts and some MATLAB grader exercises to kind of support those concepts. And then those will all come into play in the different steps of this assignment.